Good morning. So, today we will continue our discussion on energy storage devices. In the previous lectures under this topic, we have seen there are different energy storage devices. The requirement which was felt to design and fabricate different energy storage devices was that when we consider photovoltaic or solar cell and we try to connect this through the grid, there are several issues regarding power transmission or electrical energy transmission, and there are some other devices along with solar cell. There are several issues related to the environment. Of course, we discussed that green hydrogen production, which looks like a good alternative source of energy and storage of energy, but what we have seen in case of green hydrogen production, that the efficiency is not enough, or till now the efficiency which has been found in different research industry, it is not good enough for a large scale use. And thermoelectric devices or thermoelectric generators, which we have discussed before, they are basically the devices which can be used for small appliances or portable devices. So, that was the need. So, people try to search good energy storage devices which can be used at small scale and also relatively larger scale. That means, starting from home appliances to powering a particular area or region or a domain where lot of industrial activities go on. Okay, so this was the main idea behind design and fabrication of many energy storage devices, and based on these objectives I discussed several energy storage devices in my previous lectures. We have started from battery, which is a very well known device which we generally use, and then we discussed about capacitor and then supercapacitor, which is a very important device, and what we have seen that it has a capability to store energy with good power density. And then we also discussed about lithium ion battery, which is likely a new device, and then there are some evolution of lithium ion batteries like sodium ion battery and other which one can study. And then we discussed in detail about a energy storage device which is known as fuel cell. And fuel cell, what we have seen that there are miscellaneous application of fuel cell, starting from a very small scale device or the portable devices to relatively larger scale. Okay. And then we also discussed what are the materials that those are being used in all these devices, and how the performance of the device depend on what is the choice of the material. Okay. So, today what we will discuss, we will just summarize all these lectures and with some tutorial questions, and look at this entire topic which we have discussed through these questions. Fine. So, the first question is, in terms of power and energy densities, how batteries and supercapacitors are placed. So, you know that when we talk about energy density or we talk about power density, so the energy density whose unit is watt hour per kilogram, is basically the energy which a device contain per unit volume. So, how much it is producing in a unit volume is the energy density of that particular device. Okay. Another quantity is power density. Okay. So, when we discuss these two devices, that means when we compare the batteries and supercapacitor, if you look at, this is the Ragone plot which we discussed. In this plot, if you look at, the x axis is energy density and the y axis is power density, and you can place all these energy devices in the Ragone plot in terms of their power and energy densities. So, this is a position of fuel cell, these are batteries, this is supercapacitor and this is capacitor. Okay. So, now if you look at supercapacitor and batteries, you will see that supercapacitor has higher power density as compared to the batteries, and batteries has higher energy density as compared to supercapacitor. Now, the question is why the batteries have higher energy density as compared to supercapacitor. So, if you look at the battery, basically the basic principle of battery is energy storage by chemical reaction. Okay. Storage by chemical reaction. Okay. And when we consider supercapacitor, there is also an energy storage device, but energy storage is not through chemical reaction, but energy storage through electrical energy storage, or we can say the electrostatic energy storage. So, if you recollect that what we have discussed, typically in a supercapacitor, we generally have two charge layers, okay, double layer of charges, and then in these charges the energy is stored electrostatically. All right. So, generally the chemical energy storing is much more than the electrostatic storing. So, if I consider the energy densities or energy per unit volume, the batteries have much higher energy per unit volume as compared to supercapacitor, because its function is through chemical reactions. But in supercapacitor, which we see is higher power density, the reason for higher power density is it because it is electrostatic process, or you can say the electric process, where we have layers of charges in the electrode and electrolyte interfaces. Okay. So, it is faster. All right. So, that means when the delivery of energy comes to a particular load, supercapacitors are much faster as compared to the batteries. Okay. And therefore, the power density of supercapacitor is higher as compared to the batteries. Now, we come to the second question, what are the important features of supercapacitor? So, if we just look at the important features of supercapacitor, before that let me again try to draw a schematic of a typical supercapacitor. So, if you if you recollect that this is a typical configuration of a supercapacitor, we have one electrode here, another electrode is here, then we have electrolytes, and we have a separator here. Okay. So, there is double layer or electrical double layer formation. You can say electrical double layer formation. Okay. And then these are connected to battery. All right. So, in this configuration, when we consider the different features, what I just now I discussed, that it has higher power density as compared to battery, but lower power density as compared to capacitor. Okay. But the power density is higher as compared to other energy devices like batteries, fuel cell. So, the first feature, if we would like to see, that is supercapacitor is having higher power density, or let me first start with say higher charge. Okay. Higher charge, you know that the storing capacity, you can say. The reason we know that why it can store higher charge, because if we look at the electrodes which are used in the supercapacitor, they are generally carbon based material, say activated carbon, and when we consider such cathode material or such electrode material, they have lot of surface area. Okay. This is a way it has been designed. So, as the surface area is higher, it is having the capability of storing higher charge. Okay. So, as the charge is high, it eventually means that it is having higher energy density. Okay. Because we know that the whatever charge that one device can store, like just like capacitor, if it can store more charge, it will have more energy, okay, or energy per unit volume. So, this is the reason why supercapacitors are having higher energy density as compared to other devices except capacitor. And then another important feature with supercapacitor is that it is faster the operation. So, just now I mentioned in the previous question. Okay. The operation is faster because it is electrostatic process. Okay. So, the charge transfer takes place in very rapid. If I compare with the battery, which is chemical, and therefore, the power delivery or the energy delivery to any load, okay, which is connected across the battery, is generally much slower. But if we consider the supercapacitor, as it is driven by the electrostatic process, okay, it is much faster. Okay. So, that means that it can give, I mean, power delivery or energy delivery efficiently. Okay. And another important point with the supercapacitor is that it can store with much reliability. So, that means it is having higher stability. Again, when I consider or I talk about higher stability, What I mean is the stability as compared to those devices which are based on completely chemical energy. Okay? Because it is electrostatic energy, so we do not have the problem of chemical related degradation. Any of the the device you take, storage device or any other device which are based on the chemicals, we have always an issue with say degradation, corrosion and all these things, which are not there in the supercapacitor, because the process is mostly the storing of charges by electrostatic process. Okay, so these are the important features of a supercapacitor. But let us go to the next question. Classify different supercapacitor with their operational principle. Now, as I discussed, the operational principle of supercapacitor, I mean starting with the electrical double layer capacitor, which is the first supercapacitor that people have worked on. So, the EDLC, which I have just now I have drawn, that it works on the principle of two double layer formation surrounding the around the electrode electrolyte interface. Okay. So, what we do basically, you connect it with a battery and then the charge transfer takes place through the electrolyte, and then a double layer forms near the electrode, and the electrodes are so designed, as I mentioned, that electrodes are generally, if we consider the EDLC, the electrodes are mostly carbon material. Okay. So, like activated carbon, carbon aerogel, etc., graphene, so that you have large surface area, large porosity where you can store more charges. Okay. And this is a way you have made, you can do an efficient operation of the supercapacitor. Okay. So, now if I just recollect what we have discussed when we had classified the supercapacitor, broadly we know that supercapacitors are either electrical double layer or EDLC or pseudocapacitor. So, how the EDLC works? It is again electrostatic, and the main physics behind it is what we have discussed, the formation of electrical double layer. Okay. Now, when we discuss pseudocapacitor, this is the Faradic or what we call the reversible Faradic. Okay. And then it is basically it is based on Faraday's redox process. Okay. And it is a very fast, and that is why the name pseudo is. Okay. It is a very fast process which happens in the pseudocapacitor. And then when we consider the hybrid capacitor, hybrid capacitors or hybrid supercapacitors are those where we combine these two. One electrode we make something like EDLC material, which are generally the carbon based material. Okay. In another electrode we make the material which are generally used for pseudocapacitor material. Okay. So, if I can also sort of make a good classification based on how the electrodes are made. So, this is almost same as the classification how the operation works. Okay. So, I can write it here, the supercapacitor Okay. So, when we consider EDLC electric double layer, we again consider different type of electrode, starting with say activated carbon, graphene, carbon nanotubes. Okay. And we discussed all the the operation of the EDLC with different this type of electrode material. Okay. And when we consider the pseudo capacitor, there are two types, one is metal oxides and another is conducting polymer. Okay. So, this is a way one can also classify these two broad type of supercapacitor, which is EDLC and pseudo capacitor. But when we consider hybrid capacitor, as I mentioned, that the electrode material is a combination of these two, okay. One for EDLC, another is for pseudo capacitor. Operation wise, hybrid capacitors also can be classified as composite hybrid, asymmetric hybrid, and battery type hybrid. Fine. So, this is the entire the process of classifying supercapacitor. This is what have been already studied and further research is going on in this area. Okay. So, the fourth question is that what are the importance and basic features of carbon aerogel electrode in an EDLC? So, if you remember when we discussed the carbon aerogel, these are actually aerogels. So, there are small nanoparticle. So, you can look at the morphology. This is a typical aerogel morphology, where there is the nanostructures which are connected, okay, and making a network kind of structure. But there is an advantage of using this aerogel, carbon aerogel as a as an electrode, because the aerogels are generally lightweight. Okay. This is one very important feature of aerogel, for which it is not only used in the supercapacitor, but in many other devices, because it is lightweight and then highly porous. So, as I mentioned that when we design a supercapacitor, which we need to store more amount of charges, and therefore, we have to design a material which is porous, so that we can store, we have a larger surface area and we can store more charges, and then low electrical resistivity. This is another importance of carbon aerogel, because the resistivity is low. So, we have a very good conductivity of charges in the device, and also possesses a large surface area, which is obvious because it is porous and the surface area is more, and the higher surface area is required because we want to store more charges. Okay. So, again, what are the important electrode properties of a supercapacitor? Number 1, high surface area, number 2, porous structure, number 3, good electrical conductivity, and number 4, good redox activity. Now, we come to the second device, that is lithium ion battery, and we start with the basic process, what is known as intercalation. So, the question is, what is intercalation? So, what we have seen in case of lithium ion battery, the intercalation is the most fundamental physical process which goes on in a lithium ion battery or any kind of ion battery. Okay. So, it is basically insertion of a foreign element or atom or molecule in a solid network. Okay. So, when we consider lithium ion battery, what we mean is the insertion of lithium or intercalation of lithium in the electrodes, in both in the cathode as well as in the anode. Okay. And then this network is not changed, the structure is minimally defected or hampered by the process of insertion of a different element or ion inside the that solid network. Like when we consider the electrode, either cathode or anode, the structural change should be minimal. Ideally there should not be any structural change, so that it can just intercalate or insert inside the position that it finds inside the material. Okay. And what role it plays in LIB? So, if we just recollect that how LIB works, if we remember LIB again, or lithium ion batteries again, we have two electrodes. Okay. So, this is one electrode, this is another electrode. This is separator, and then we have electrolyte. Okay. And then when we discharge it, say suppose through any load, all right, that we know that the electron flows in this direction, and lithium ion, which was intercalated in the electrode, say anode, it through the super separator it reaches to the cathode. All right, and then it is inserted in the cathode, and then the electron which is coming, okay, with lithium ion, it get neutralized. So, that means the intercalation plays a very important, and it is true for the charging process. It is just opposite. In that case, we have to connect a small battery with the two electrodes, and the lithium ion movement is exactly in the opposite direction. It moves from the cathode to anode, but it gets intercalated. Okay. So, therefore, we should have the electrode materials, be it cathode or anode, which has the capability for intercalation of lithium ion in that material. Okay. So, these are important role which intercalation plays in case of operation of a lithium ion battery. So, now we come to what are the important the physical criteria behind selecting cathode materials of LIB. So, I discussed this, that how the basic operation of a lithium ion battery is. So, what we have seen, it is basically the movement of the lithium ion, the movement of the lithium ion in the electrolyte, okay, and then the intercalation of lithium ion in the electrode. So, the features of the electrode material should actually comply with this particular physical process. So, it should have high lithium content, this is the first one. Second is large diffusion coefficient of particular ion, whatever ion we use. So, we have to look at that what is the diffusion coefficient of, say, lithium in one of the electrode material, which is popularly that graphene, which is used very popularly as an electrode material or anode material for lithium ion battery. Okay. Like that, whatever cathode material we choose, okay, which we have discussed in detail, all right, we have to check the diffusion coefficient of the lithium ion in this. And then good structural stability, this is essential because I told you that it works on the process of intercalation. That means, a foreign ion is going and getting inserted inside that particular structure, all right. And therefore, it is important that it does not make a structural instability of that particular material. So, it should have a good structural stability, it should have a very good electrochemical performance. This is mandatory because it is nothing but and then electrolyte and electrode interface, which the electrochemical process is going on, and then followed by the intercalation. Okay. So, it should have a higher electrochemical performance and also thermal stability, which we know that is a very important feature. And I will just show again, we will just discuss again what are the issues that all these processes are involved, and what are the issues these are related to safety of the lithium ion battery. Okay. Now, we go to the next question. So, we know that lithium ion battery, it has started with an electrode material which is LCO, lithium cobalt oxide, and then people found that there are other transition metal elements also which can be used in the lithium ion battery. So, the question is tabulate a comparison of properties of cobalt, nickel, manganese. Okay, these are transition metal when used as cathode. So, this is a very important thing when we design a cathode material, okay, and we change the transition metal, say cobalt to nickel, nickel to manganese, or we have seen that you use a combination of the of two transition metal. Okay. So, what are the properties that we look at? That when we consider chemical stability, manganese is better than nickel and nickel is better than cobalt. Okay. So, we know that when the work started, lithium ion battery work started, and I mentioned that the industrially it was the lithium cobalt oxide was the first adopted material, okay, because of various the advantages, but then the idea of other transition metal came, and the one thing is that when we look at the chemical stability, manganese is better than nickel, which is better than cobalt. But now when we consider the structural stability, cobalt is better than nickel and nickel is better than manganese. This is a very important point, because again this intercalation process, lithium goes and then it gets inserted inside that material, and therefore, the structural stability should be high. Okay. And then when we come to electrical conductivity also, the cobalt is better than other two, cobalt is better than nickel and nickel is better than manganese. Coming to abundance, this is an issue always with the cobalt, okay. And this is the reason why people started working with other transition metal, and then they realized that let us have a combination of transition metal. The important thing is that two very important the properties like structural stability and electrical conductivity, where cobalt is better than other, okay, but the abundance is low. Manganese is the highest abundance, followed by nickel and then cobalt. And then environmental benignity, there also manganese is better than nickel, is better than cobalt. Okay. So, definitely you get in terms of structural stability and electrical conductivity, you get a better performance with cobalt, but then the other factors which I discussed, where other transition metal like manganese or nickel show a better the property as compared to cobalt. Okay. And therefore, the combination of the transition metals is a good choice, which we have discussed in detail during lecture. So, again let me tell you what are the points. Porosity and conductivity should be better. Second is it should have a higher capacity. Third is it should the higher durability. Fourth is low cost. Fifth is safety, and sixth is good structural stability. Define open circuit voltage of LIB. So, open circuit voltage is the voltage which we always define for any devices starting from the solar cell. So, what is open circuit voltage? When there is no current in the device. Okay. So, when it is only the some kind of chemical potential which decides the voltage of the device. So, here what is the chemical potential that decides? So, if I have a chemical potential corresponds to anode mu A, and then we have electrolyte. So, I can have a level here that is HOMO, and then I can have another level here is LUMO. Okay. This is electrode, electrolyte, and this is another electrode, say cathode, and I define another potential here mu C. Okay. So, now when you consider the difference between these two potentials, this is the open circuit voltage. Okay. So, if you remember that when we discussed dye sensitized solar cell, we have two energy levels, Fermi level and redox level. So, with comparison to the Fermi level of the semiconductor and the redox level of the electrolyte, the difference gives us the open circuit voltage. Similarly, this is the open circuit voltage for a lithium ion battery. So, now we come to that what type of material that one can design. So, in that case also we have discussed a lot about nanomaterial which are being used in lithium ion battery and what are the requirement of nanomaterial to use as an electrode material in the lithium ion battery. Okay. So, there are certain reactions which are not possible for bulk materials and or the reaction efficiency is lower, which people have found is more when they consider the nanomaterial of that particular bulk material. And then a very important point using the nanomaterial is that it is having the larger electrolyte electrode electrolyte contact area. This is always important, and because if we have a larger electrolyte electrode contact area, then we can have always higher charge and discharge rates. Okay, higher charge and discharge rate. And then we should always look at the in terms of the conductivity, because these are the property which we need to improve. And then when we consider nanomaterial, different design nanomaterial, that this can have a shorter path length for both electron and lithium ion transport. Okay, this leads to higher lithium storage capacity and higher electrochemical activity. Okay. So, these are important properties which we would like to achieve in case of nanomaterial when they used as the electrode material for lithium ion battery. Okay. So, now the last thing of lithium ion battery is electrolyte. So, what are the important properties of electrolyte? Okay. So, the electrolyte, as we know that again if we go back to the fundamental process, it is basically the diffusion of lithium ion in the electrolyte. So, therefore, it should be a good ionic conductor, and the electron goes in the outer the path, and therefore, it should be then the electronically it should be an insulator. Okay. Another important thing is that for the efficient performance, it should have a wide electrochemical window. Okay. And then the third property is that it should also be inert to other cell components. This is extremely important, because in all the cases wherever the device we used in electrolyte, we have to choose that it should not react with other components which are there in the devices. Otherwise, it may degrade the performance, it may corrode the material which are facing to this electrolyte. Therefore, one is to check, and then it should be thermally stable, it have lower toxicity, and the finally is that the electrolyte whatever we use should have the the lower cost. Okay. So, these are the important properties of the electrolyte which are looked at when we design the LIB and use a particular electrolyte for that lithium ion battery. Now, again I come back to the safety issue. This I discussed in the lecture class also, but again let us look at that what are the safety issues. So, you can make it in the 4 section A, B, C, D. Okay. So, one could be the accident, disasters, defect of cell, poor control system. So, what they are originated from, that could be a damage in the the shell, or a thermal shock, that means some kind of local heating which can take place, and in overcharging effect. Okay. Because it is continuously charging and discharging process. So, this may also cause any kind of accident or safety issues or defect of the cell. There could be a mechanical abuse, there may be a thermal abuse or the electrical abuse. These are the 3 things which we have discussed, and then this may lead or the impact on different components of a lithium ion battery. Okay. So, suppose when we consider the mechanical abuse, we can have an impact on the interface, we can have an impact on the separator and another interface, because there are two interfaces in a lithium ion battery. When we consider thermal abuse, we can have an impact on anode, we do have an impact on interface, on lithium plating, interface and cathode. Similarly, the electrical abuse can be also in the interface, electrolyte, interface, etc. Okay. So, these are the all safety issues, and then what we essentially see is what is known as the cell thermal runaway. Okay. So, if all these the safety issues are not taken care of, there is a possibility of thermal runaway which catches oxygen and then smoke, fire, explosion, etc. may take place. Okay, so, these are the important safety issues which one should take care while operating a lithium ion battery. Okay, now we come to a comparison in terms of various the parameters, okay, or the physical quantities of different storage devices which are the popular storage devices. The question is, make a comparison between some popular storage devices under study. Okay. So, we discussed about fuel cell. So, I start with fuel cell, although the tutorial section of the fuel cell will be in the next class. So, if you look at DMFC or direct the methanol fuel cell, this gravimetric energy density is quite high, 1000 more than 1000 watt hour per kilogram. Volumetric energy density is also quite high, 700 to 1000. Power density is quite low, 100 to 200, and cost, capital cost is $200 per kilowatt hour. Now, we come to lead acid battery, okay, where we have a quite low energy density, 20 to 50. Similarly, the volumetric energy density is low with higher power density as compared to DMFC, and cost is lower. We come to nickel cadmium battery. This is slightly almost in the same range of energy densities, okay, and power density is also in the same range, cost is slightly higher. And nickel metal hybrid battery which are being used the commercially, it can have slightly higher energy density, more power density and higher cost. Then we come to lithium ion battery. Lithium ion battery, the energy density is slightly higher as compared to these other batteries which are being used, okay. And then energy density is also higher than that, okay. Power density is quite high, it is higher than all these, higher than the fuel cell as well as all the conventional batteries that we use commercially, but with slightly higher cost. Flywheel is anyway this is a device which we are not discussing here, but a mechanical device which are having this range of energy densities which are reasonable, and then higher power density as almost same as what we see in case of lithium ion battery, but the cost is higher. And then we come to ultra capacitor or super capacitor, it is having quite low energy densities as compared to others, okay, but it has a very high power density. Okay. This is the advantage of a super capacitor, and however, the cost is quite high. Okay. So, this is the way when we would like to use any storage device for any practical purpose, we have to look at all these essential features before designing or application in a particular device or equipment. Now, this is the last question today. So, what is to make a comparison between fuel cell, battery and heat engine. Okay. So, in the next class we will start discussing more about the fuel cell and summarizing the entire chapter. So, let me just make a comparison between fuel cell, battery and heat engine. Again the comparison comes in terms of function. Fuel cell works in terms of energy conservation, battery works in energy storage and conversion, heat engine works based on energy conversion. Now, when we consider the technology, fuel cell is basically based on electrochemical reactions, battery is again electrochemical reaction, but heat engine is based on combustion. Now, when we look at the typical fuel which are being used, in case of fuel cell we know it is simple, it is only pure hydrogen, and for battery it is stored chemical, and heat engine gasoline, diesel, etc. These are the typical fuel. And when we talk about useful output, we get the DC electricity from fuel cell, battery also we get DC electricity, but when you consider heat engine, what we get is the mechanical power. So, what are the important advantages of fuel cell? It is having higher efficiency, reduced harmful emission, battery higher efficiency, high maturity, and heat engine high maturity and low cost. These are the typical advantages of these three devices. And what are the main disadvantages? Fuel cell is high cost and low durability. Battery is low operation in cycles, because I mentioned previously it is based on completely the chemical process. The operational cycles are low and durability is also low. Okay. Then we consider heat engine which are being used, they have significant harmful emission and the efficiency is lower. Okay. So, let us stop here today, and in the next class we will continue our discussion on the same topic, starting from fuel cell and then summarizing the entire chapter of energy storage devices.